We are back to Haskell. Let's try and do some less complaining today. Less complaining today. And we're doing still higher order functions. And we're doing functions applied with the $sign. Right, next up we'll look at the $sign function, also called function application. First of all, let's check out how it is defined. Okay. This was a different way to do it. Okay. We have one type and... wait, no. We have a function that gives us one type to another. And then we take that one type and... wait. I'm super confused. We have a function... and we do the $sign on x, and we get just a function of x. More complaining? More complaining! No, I'm just confused. What the heck? Is this a useless operator? Right? No, less complaining. Isn't that what we want in life? Less complaining? I don't mind some complaining. It's part of life, and it makes you feel good. Justified complaining? Yeah. It is just a function application. Well, almost, but not quite. Whereas normal function application, putting a space between two things, has a really high precedence, the function has the lowest precedence. Shit, what does that mean again? We're opinionated. More complaining. Well, yeah. I mean, it's a good thing to be opinionated, I guess. So complaining is a good thing. I guess it can become... as long as you don't let the complaining drag you down, eh? $sign is a neat way to make code so much prettier, is it? Function application with a space is left associate, so function on A, B, C is the same as this. Wait. Well, a function with a $sign is right associative. Oh, damn it, we're back to this. Wait, left associative. I don't got that. I think I just skimmed over that and never got the left and right associative stuff. So what would happen is, what? If we called F $sign ABC... wait, no, that... I was thinking that it was gonna flip it around, so it was FC, FB, like this. No. Like it would have put the function in the center of, but... Let's keep reading, I guess. That's all very well, but how does it help us? Most of the time it's a convenience function, so that we don't have to write as many parentheses. Consider the example, the sum of the... wait, I have a list from 1 to 30. We got the square root. Alright. Because the $sign has such low precedence, we can rewrite that expression to... some $sign map square. So it's flipping order of operations. Oh, that's what it does. It's just a function application. Shit, this is more syntax stuff. Alright, saving ourselves precious keystrokes. Something tells me that they're like me, they hate Lisp. Whoever did this thing, they were like me and just like, well, hate Lisp is a strong word, but they like, man, there are too many parentheses in these languages. Let's fucking get rid of them. Get rid of them, all the parentheses. Right, when a dollar sign is encountered, the expression on its right is applied as the parameter to the function on its left. Right, so this is the expression, right? Yeah, this is the expression, and we apply the sum on this expression. Now Donner says Lisp is like this. No. I think you had too few parentheses. No, Donner, yeah. He only had like what, 4? Yeah, he only had 4 parentheses in that message, and that's not Lisp. You would have to have like 6 parentheses to make it look like Lisp, wouldn't you? Alright, it's pretty much, we put the dollar sign here instead of this parentheses. That's... Is that it? How about square root of... Wait. Yeah, it adds together 9 and 4 and the square root of 3. If we wanted to get the square root of 3 plus 4 plus 9, we'd have to write square root and then the parentheses. But we could instead use the dollar sign, because square root has the lowest precedence of any operator. That's just what... It's just an order of operations, thanks. That's why you can imagine the dollar sign being sort of equivalent of writing an opening parentheses and then writing a closing one at the far right side of the expression. Alright, if it starts getting messy, I can see why you would want to fix that, but like in this example, I mean, I like this more. Just 1 parentheses. I like that. Exactly, there you have it, Node-Runner. All the parentheses. Colgate InnoTab says you can replace the parentheses with the dollar sign. Yeah. Nix.is like equal to this. Semicolon. Yeah. Python is like, and then a snake. Yeah. Mm-hmm. This is why you can imagine the dollar sign being sort of the equivalent of writing a parentheses. Yeah, exactly. How about some... Wait. We can interchange them. Is that it as well, right? Some dollar sign and then all of this. Wait. Some dollar sign, filter dollar sign, and so on and so forth. Well, because dollar is right associative, wait. If gzx is equal to, yeah. Yeah, some dollar sign, filter dollar sign, parentheses. Alright, so we can rewrite this into... Oh, right, of course, this is the function. Sorry. Yeah, that's the function and dollar sign map. I mean, like you say, it is prettier. You just have to get used to it, I guess. It becomes prettier, right? This is more of a mess than this. Look at this. Right? End of a square bracket, end of a parentheses, end of another parentheses. Here, it's just a square bracket and we're done. Like that. Now Donner says that Haskell is just monads all the way down. We still haven't gotten to monads. Wow, still not, eh? Deltarune music. Yes, indeed. But apart from getting rid of parentheses, the $sign means that a function application can be treated just like another function. That way we can, for instance, map function applications over a list of functions. Wait, now you lost me a little bit. What are we doing? We map... Alright, we map 3 onto these. So we can... 4 plus 3, that's 7, yeah. Multiplied by 3. Right. Yeah. I get it. You just put the 3 in because these are partially applied functions, right? And you just apply the 3 onto this function. What function is this? Mondas? No, monads. Okay, then says, yeah, monads are advanced stuff. Oh, nice. So we don't have to do that yet. Okay. I kind of feel like... I hope you don't mind, but that was annoying. There we go. They are the answer to everything after all. Yoshi! Yeah, that was a little bit... in my ears. In my face. It was... Chill out, damn it. Right, apart from it... they can be treated just like any other function. Yeah, so it's... It's a non-function that, well... low associative. And, well, it's... No. It's lowest precedence. And it's right associative. That still confuses me, how the right associative stuff helps. Coleman says, I thought it was a remix of Big Shot for a second there, until it gained more vocal sounds. Genova! Yes, indeed. Oh, right, and we can just apply 3 to square root, and we get the square root of 3. Nice. Right, that is something definitely to keep in mind when we do some typing stuff, yeah. NodeRunner asks, are you familiar with Big Yoshi? No, I am not. Maths next session. Oh no, maths! Damn it. Gotta complain about all that math. Coleman says, Sag, now I want to listen to Big Shot. Good times, I guess? I don't even know what that is. Function compositions in mathematics. Oh no. Bury yourselves. Function composition is defined like this. Right. Bog x is bigx, meaning that composing two functions produces a new function that, when called with a parameter, let's say x, is the equivalent of calling g with a parameter x and then calling f with that result. Right. Composing two functions, compositions, alright, so f and g on x is the same as calling f on g with x. I'm assuming this means and. In Haskell, a function composition is pretty much the same thing. We do function composition with the dot function, which is defined like so. The dot, eh? Notice says, prepare for enlightenment. Enlightenment, eh? Oh, big Yoshi. Okay, that's... Yoshi just had a few too many snacks. Wait. Olgetino tabs says that's my least favorite syntax in maths. Oh man. That's saying something, isn't it? Right, how is this defined? Function composition. We take function and we take another function, but we make sure that... What did the backslash do again? I don't remember. I don't remember. Wait, we call the function on the called function with G. Remember. Is Yoshi a male or a female, by the way? Still confused on that point. Isn't it like the frogs, right? Androgynous? He's both. Well, they're both. Right, the one that shifts because like a male that can lay eggs. Maybe. Because if F and G are used as relations, I don't know what that means. Relations to that syntax have different meaning. Oh. F and G have different meanings? What? And all functions are relations, so you need to know the context. Okay, I'll take your word for it. Right, let's see here that we take a function that takes a B thing and returns a C thing. And a function that takes an A thing and returns a B thing. Let's just take A and return a C thing. Right. I'm confused. Mind the type declaration. Wait. Type declaration? F must take as its parameter a value that has the same type as G's return value. It takes a value and that's the return value. So the resulting function takes a parameter of that same type G takes and returns a value of the same type that F returns. The expression negate dot multiply by 3 returns a function that takes a number, multiplies it by 3 and then negates it. I'm confused. There's a pink girl, Yoshi? Birdo? Oh, so then Yoshi is a male then. Yeah. I mean, I'm not I don't know Super Mario lore. Yeah, I don't know any of it. I didn't have a Nintendo as a kid. I played Sonic as a kid. But to be fair, I don't know any Sonic lore either, so I don't know. Wolfmonkey says the FX notation annoyed me at first, but it was whatever once I got used to it. Oh, this syntax, yeah. There is lore in Mario. So I hear. He's a plumber, right? That's lore. He rides a lizard. He has a brother. He tries to save the princess. Lots of lore, yeah. When the princess is just in another castle, that's the lore. He has a terrible sense of direction, yeah. Mario has terrible sense of direction. Just wrecking castles that has no one in them. He's kind of like a Path of Exile character, just wrecking the place. Ah. Kind of the bad guy in the stories, right? Yeah. This was a little bit extreme as well. Just... Oh, it's still the same song? Okay. Alright, it returns... Wait, it takes a number, multiplies it by 3, and then negates it. What's the dot? I don't quite get what the dot means here. Function composition, right? We take one function and we take another function and we join them together. Is that what we're doing? One of the uses for function composition is making functions on the fly to pass to other functions. Sure, can use lambdas for that, but many times function composition is clearer and more concise. There we have a list of numbers and we want to turn them all into negative numbers. One way to do that would be to get each number's absolute value and then negate it. Like so. What does this mean again? I forget the syntax, I don't recognize it. Backslash X. And the arrow thing. Oh, it's a lambda function. Right. It looks like a lambda. Right. Thanks. We did it yesterday. And I promptly forgot about it. It even looks like a lambda. The Gordon Freeman and everything. Alright, so we map a lambda function that is the negate the absolute value of x. Alright, to get all of them to be negative numbers. Yeah. Isn't this looking pretty good? Yeah, negate all of them. Notice the lambda and how it looks like the result function. Wait, how it looks like the result function composition. Using function composition, we can rewrite it like this. Wait. Does it? Right. What are we doing here? We take map and we negate and we call... Oh, right. That's just what we do. This actually feels like a description, right? Yeah. We map both of these functions on here. And I guess we take the right one first for some reason. Yeah, we take this one first. So we get all the absolute values and we negate them. It's just, yeah, function composition. We take two functions and we run them on this list. Well, we don't run them, but right. This expression is this list, but all the numbers are negative. Mr. Freeman. Still haven't played that game. Banana Waffle Monkey says that math is just an elaborate ruse to teach people Greek. Alright, that was a pretty good description. Oh, we're back to this rotation. The Persona 5 music. Nice. Fabulous. Function composition is right associative. So we can compose many functions at a time. The expression... Alright. Is equivalent to just putting it like this. With that in mind, we can turn... Wait, what is this? Long functions. Right. We map to these lists. Wait, just the sum of the tail, and we negate the sum of the tail for the entire list? Okay, and we map. All right, here we go. Yeah, negate the sum. Oh, wow. Suddenly, it looks like English, doesn't it? Negate the sum of the tail. And we map that to this list. Oh, wow. That. Oof. Looks like English. Doesn't look like maths. Doesn't look like programming. Looks more and more like English, doesn't it? Right. But what about functions that take several parameters? Well, if we want to use them in function composition, we usually have to partially apply them just so much that each function takes just one parameter. Okay. So sum replicate 5 times, and the max, these two, alright, can be rewritten as, right, sum of, wait, that got confusing though. Oh, we replicate, right. We take the max of these, but we do it 5 times, and we get the sum. Oh, here we go, and that's the dollar sign to get rid of the last. Get rid of the last parentheses. Oh man. What goes on in here is a function that takes what the max 6.7 takes and applies replicate 5 to it. Wait, to it is created. Then a function that takes the result of that and thus a sum of it is created. Finally, that function is called with 8.9. Yeah, exactly. But normally you just read it as apply 8.9 to max 6.7 and then apply replicate 5 and then just apply sum to that. Right, there's so much, you read it in reverse, this language. It's way easier to understand what's going on if you start over here and read it. Well, wait, the dollar sign we can put on, yeah, oh, right. It doesn't matter. The dollar sign is just like separating, right, the thing on the left from the thing on the right, because it's just an order of operations thing. So this will all be done separately, and then it will be applied on this, right? Or the other way around. This will be applied separately and then on all of this. But I was like, is this lol? They really threw this song in? I don't even remember this song. It's a bit of a mess, isn't it? Oh, it has the lowest preference, so it's done last. But it's right associative. Right, but that's, it doesn't matter that it's right associative, does it? Not in this function anyway. UIU. Just Node Runner. Nothing can show you on stream. It's a porn meme? Oh. Oh, it's a porn meme. Did not know. I guess that's funny. Yeah. Maybe we should not go over here. Yeah, it takes... But on this side, we read it like this. Yeah, we get the max out of... Right, we create a function that takes max 6, 7. We replicate that 5 times. Wait, and where does the sum come in, right? We have to take them... It kind of feels like we're jumping around. Because these are... Wait. It's this, max... If we take this function is done 5 times. And then we get the sum of all of it. Or do we get the sum... No, we get the sum 5 times, so we get a list, right? Alright. Right, normally you just read it as apply 8.9 to max 6, 7, yeah. And then apply replicate 5, yep, to that, and then apply the sum to that. Exactly, so we just get one number, we don't get a list. We'll get in on tab says it matters if and only if you have multiple $signs. Right, exactly. It only matters then. We did show that. What did that look like again? Because we did have a couple of them before. That's when it mattered. Here we go. Right. Somehow it's like these things where it says right associative. My mind cannot. It's like greater than less than. Which way do we go? Somehow my mind can't grasp that. It's frustrating. Right, so I guess here we go. These two are put together. Because it's right associative, that means the Z and the X. I don't know. I guess that's just like with greater than and less than. I would just, instead of just getting it, since somehow I can't, you'll just notice when you do it, oh, that's not what I wanted, and then you just flip it around, kinda. Right, if you want to rewrite an expression with a lot of parentheses by using function composition, you can start by putting the last parameter of the innermost function after a $sign, and then just composing all of the other functions, writing them without their last parameter and putting dots between them. Right, if we have this mess, where we take, oh yeah, zip width. I was wondering, wait, how do we do max on a list? No, zip width. Yeah, so we take 4, 5, 6. Yeah, we take, it's all of these. We're going to take all of those. Then we're going to map. All right, we're going to multiply by 3 on all of them. On this list, right? Because it's just this list. Pretty much. Wait. Zip width? Does that create tuples? I don't remember. No. Right, we map that to... We only get one list. I'm pretty sure. Then we take the product of this entire list. Oh, wow. And we do it 100 times. Oof. What a mess. All right. You can write it as replicate 100 dot product dot map multiply by 3 zip width max, and there we go. And we take the $sign. Yeah, exactly. Just to make sure that we bring both of our parameters in. If the expression ends with 3 parentheses, chances are that if you translate it into function composition, it'll have 3 composition operators. Oh, 1, 2, 3, exactly. This is... It really feels like learning to program all over again, because it's very alien, foreign. Yeah. Another common use of function composition is defining functions in the so-called point-free style, also called the pointless style. Take, for example, this function that we wrote earlier. Alright, yeah, we have a sum of our list where we fold our list. Fold left. We added plus. Oh, right. We started with 0 because we needed to start with something. What was this called again? It was the ATT, I think they shortened it as. The attribute? I don't remember. It would start with 0 and we take the first of the list and add it to it, and then we just go through the entire list and add them all together. Right. First I misunderstood it as being the index of the list, but it's not. It's just the value that we're trying to... Well, it's gonna be the value that we're gonna be returning. Right. The excess is exposed on both right sides. Yes. Because of currying, we can omit the excess on both sides. We can... I probably won't. Because of fold left plus 0 creates a function that takes a list. Maybe... No, it's better to do it best practices. Yeah, just take these away. Take them away. We don't want them. Because we know that fold left needs a list. Yeah. Lazy. No. Type inference. Writing the function as sum fold left plus 0 is called writing in point-free style. How would we write this in... Wait. It's called... How would we write this in point-free style? Okay. Right. Function x. Ceiling. Oh shit, this is maths, isn't it? So what we do is just that we remove the x's first of all, right? We just get rid of them. That's fine. And then we just get rid of all the parentheses. We put a dot in here, we put a dot in here, we put a dot in here. We put a dot in here. That's it. We don't even need to use the $sign, do we? I guess we could do the $x. If we want to keep the x in here, we could just write the $x to make it work. And that's an easy way to rewrite. Like, they made a simple exercise. I didn't understand what I was doing. I was just doing what they did before. I don't understand why it would work, but yeah. Like functional? Let's see. We can't just get rid of the... Oh, we can't? On the right... on both right sides, the x in the function body has a parenthesis after it. Os max 50. Wouldn't make sense. Oh yeah. Wait, but max takes 2 values, right? And since we know that 50 is an... what was that again? It's a number, yeah. It's not a num type class, but it's a type class. And we know that we need something else from that same type class, right? Can't get the cosine of a function. What we do is express fn as a composition of functions. No, we are doing it. Yeah. I was thinking that... said that we can't just get rid of on the x of both sides, but Then he got rid of the x on both sides, right? Because we know that max takes two values, that we need another value of the same type class as 50. It's implied. Right. This is actually, when you look at it, it is kind of beautiful. Look at all those parentheses just gone. Just gone. Oh, we can't get rid of the x if we keep the parentheses. Right, because... Yeah. It has to be standalone. Can't be within. Yeah, it can't be... I mean, here we have it in the center of a nested parentheses function chain. I don't know what to call this, but right, we have the x within the within this nest here, and that would break it, yeah. But here it would be $x, right? So the x is out and free. You're not stuck anywhere. It's just it's a standalone value. Like here, it's a standalone value, therefore we can get rid of it. But if it's not, then we can't. Alright, I get it then. Excellent. Many times a point-free style is more readable and concise. I mean, yeah, getting used to reading this, definitely. Because it makes you think about functions and what kind of functions composing them results in, instead of thinking about the data and how it's shuffled around. Yeah. That is definitely what happens. You can take simple functions and use composition as glue to form more complex functions. However, many times writing of functions in point-free style can be less readable if a function is too complex. That's why making long chains of function composition is discouraged, although I plead guilty of sometimes being too composition happy. The preferred style is to use let bindings to give labels to intermediary results, or split the problem into sub-problems and then put it together so that the function makes sense to someone reading it, instead of just making huge composition chains. I like that, yeah. Like that. That makes sense. Colgatino says, I like this because I often made mistakes with counting the round amount of parentheses in languages like C and Java. Yes, and Lisp. Yeah. This is awful. I hate this. We actually have that problem in Nix. The Nix's expression language. I ran into this problem yesterday and just noticed that, well, hate is a very strong word, but I don't like it. It's a mess, right? Especially when you have... Right, when you have... Let's say you have, what, 15 lines of code, and in the end you have... Like, it's not only parentheses, right? You got square brackets ending, and you got curly braces endings. And you got semicolons in the end, right? And you have all of them put there, and it's like, what fits with what? What is supposed to fit with what? I'm not so sure anymore. Yeah. Outrunner said that Nix is like this. Yeah, but when you make longer functions, does Nix have similar compositions? I have no idea. I have no idea if Nix have similar compositions. I haven't learned the Nix language, right? I'm kind of just hacking it together without knowing what I'm doing. Thing is that it kind of just works. It kind of just works. So, yeah. Maybe they do. Maybe that's what's going on with the dot value. No. Maybe it is. Maybe that's what's going on, because we do have next dot is like, no, they are derivations, I think. The thing is that this in that example can be like a long function with a lot of stuff going on, a lot of expressions within said function. Yeah. Alright, in this section about maps and filters, we solved a problem of finding the sum of all odd squares that are smaller than 10,000. Here's what that solution looks like when we put it in a function. Into a function, okay. Odd square sum, and it takes an integer. Why an integer? Who knows? Integral was what I was thinking about before. Integral is both an integer and an int. Right, odd square sum. Oh, here we go. Check from this way. We map the square of the infinite list. Yeah. And we remove all the... Wait. We filter the odd ones. Wait, how does that work? The sum of all odd squares. Oh, I was thinking, wait. I was thinking multiplied by 2, and I was thinking we won't get any odd numbers if we multiply by 2. But that's not what we're doing. It's that's a caret, not a multiplication sign. We're squaring it. So yeah. So we filter odd is remove all the odd ones, right? No. It's the other way around. We filter, we keep odd and filter the other stuff out. Is that a bad name, or is it me a misunderstanding? Right, because in my mind, right, when I read it, all right, filter odd. That means that we filter the odd ones out. Not take them in. That makes sense? But it's my brain, right? I can't understand greater than, less than, so I guess me making that mistake with filter as well is to be expected, yeah. Alright, but we will only take while it is less than 10k. And we want the sum of. Right, and if we were to... Right. Oops. Oops. No, wait. Shit. Let's do this instead. A little bit bigger, maybe. Oh shit, this was not gonna work like this, right? If we want to rewrite this whole thing, what we do is fairly easy, right? We take sum, take while, oh, we keep this parentheses because I want to. And then we filter. Wait, will this work? Map. Right, we keep this parentheses. Right. That's the, whoops, nope. And that's it, right? I'm pretty sure that's how we do it. Yeah. Being such a fan of function composition, we would probably have written it like this. Yeah, exactly. We're doing the exact same way. However, if there was a chance of someone else reading that code, I would have written it... Right, we would have changed it around. Alright. If someone else was gonna read it, we would make it more readable by... Right, let odd squares. Filter odd. And map these things. Oh yeah. And we have a below limit. And... Alright, and there we go. Sum below limit. Yeah, I guess this is a little bit prettier. Colgate Innotab says, usually when I use filters in interwebs, it keeps those that I filter. I don't think it works. Or you could use where. Yeah, exactly. Right, that would be sum below limit, where below limit. Wait, I wonder. Right, if we take this thing... Oh, actually, let's quit and... test. Oops. Let's make it a little bit bigger. Right, and we just put it in here and... Just to memorize how this is done. Here, we do sum below... limit where and wait, like this. Oh, actually, let's just remove that. Here we go. It's lazy, right? It doesn't matter which order we define these in, or do we have to define below limit before we define odd squares? Right. Colgate Innotab says, like, if I filter games in Steam by tag, it keeps games with that tag. It does, yeah. Fortunately, they don't have an option to filter games out by tag. Oh, it doesn't matter which order we do them in, because Haskell is a lazy language. Yeah. I would say... I would personally probably do... Alright. Oops. Do it like this, because sum below limit, where below limit, right? It would look nice to go below limit here, and we have this. And we have odd squares here. Alright, so then we define odd squares. It becomes like a chain when you read it, kinda. Right, don't need that anymore. Right, it wouldn't win any code golf competition, but someone reading the function will probably find it easier to read than a composition chain. Yeah. Alright, so we do have a lot of choices on how to do these things. Yeah, that's too bad that Steam doesn't have that. Like, I don't want to see this type of game and just filter that out. Right, let's take a sneak peek on modules. Oh man, I'm looking forward to modules. Are there a lot of modules to Haskell? I mean, that's one of my favorite things with Python, that it's just endless amount of modules, I assume. Right, loading modules. A Haskell module is a collection of related functions, types, and type classes. A Haskell program is a collection of modules where the main module loads up the other modules and then uses the functions defined in them to do something. Having code split up into several modules has quite a lot of advantages. If a module is generic enough, the functions it exports can be used in a multitude of different programs. Exactly, yeah. It's like libraries in C, right? If your own code is separated into self-contained modules which don't rely on each other too much, we also say they are loosely coupled. You can reuse them later on. It makes the whole deal of writing code more manageable by having it split into several parts, each of which has some purpose. Exactly. And other people write modules if they're generalized enough, or modules that have specific purposes that you don't have to rewrite yourself. So a lot of programming then becomes that you just import a lot of modules and learn to use the modules instead of reinventing the wheel over and over and over again, right? Is this... oh wow, this is a long one though. So I don't think we start with the imports just yet. I think we... yeah, start with the modules tomorrow and go to lunch. Yeah. So thanks for hanging out. Hope you had a good time. I had a good time. I didn't complain as much today at all, did I? Yeah. Right, so have a good one and see you next time. Yeah, cheers.